Mr. Investor, welcome back to the channel, baby. Last night, I went exploring. I wanted information on bionano genomics. So I went deep inside that rabbit hole. And oh my goodness, what did I find? I found a top university in the UK using bionano genomics saphyr. One of their projects is a 4-year project worth over $1 million. And these guys got a juicy amount of funding for a disease called craniosynostosis. Now, you know me, I don't just stop there, baby. I want to get the best information and create unique content on this channel. So I went and emailed a member of the team, baby. So I hope you find this content valuable and entertaining. Remember, it's not financial advice, it's for entertainment only. And I want to thank you guys for all supporting the channel. If you want to send me any tips or donations, please use the PayPal link in my description box below. I also thank all of my channel members. You can join channel memberships for only 99 cents a month, or you can choose any tier that you can afford to support me with. My studies are nearly finished, and when I finish in December, I'm going to make sure I'm going to be posting some of the best content you'll find on bionano genomics and some other gems of companies around. Please also hit that like button and leave me a juicy comment down below. First things first, bingo, earnings call coming up. I wanted to find out about bionano genomics, the people who are using bionano genomics saphyr system and what they're currently exploring, as well as how much funding they have. So I found one in the research.genomicsengland.co.uk registry, and here I found a project lead called Andrew Wilkie. The project was submitted on the 26th of the 7th, 2021. This is not their first project, this is actually one of the most recent ones. The project involves ONT nanopore sequencing in patients with unexplained craniosynostosis. Craniosynostosis is a birth defect that happens with babies. It's a birth defect in which the bones in a baby's skull join together too early. This happens before the baby's brain is fully developed, and as the baby grows, the skull can become more misshapen. So what does this mean for the baby? How serious is it? Well, if left untreated, craniosynostosis can lead to serious complications including head deformity, severe and permanent, increased pressure on the brain, and seizures. Now take note of the date this was submitted, 26th of the 7th, 2021. And so these guys were getting, this short read sequencing data on the 100,000 genomes project. Although they're good for finding small variations in DNA, they're less reliable for identifying larger variations from the range of 100 to 100,000 individual DNA chemicals. They stated that there's dark matter regions of the genome that are currently being missed in this 100,000 genome project patients. So this latest and new project is attempting to find diagnosis in the 100,000 genome patients that are affected by craniosynostosis. They have 114 patients enrolled into the main program, but the diagnoses are still lacking in 77 of them. So in order to solve them, they're going to be using long read technologies that can cover these dark matter regions of the genome. And in this project, they're going to be looking at two long read, long range technologies. One is termed bionano optical mapping and ONT nanopore sequencing. So this is a recent submission, as you can see, the 26th of July 2021. But you know me, I go over and beyond, so we had to go back in time, and on the UK Research and Innovation website we looked at projects. Principal investigator Andrew O.M. Wilkie, and this project is called Uncovering New Mechanisms of Craniosynostosis Associated with Structural and Copy Number Variation. They're going to use mouse models and human neural crest cells. So make sure you watch to the end because you don't want to miss this. Now let's take a look at the date and let's take a look at the money involved. The project has been funded. The funded period is from November 2020 till April 2024. So let's have a little background into craniosynostosis. In this study, they've stated that this is a serious condition. It's also known as CRS. This condition affects 350 babies annually within the UK. And there's actually many different causes. It's not only genetic, but about 25% of it occurs because of altered genetic instruction. So this kind of fusion, this joining together of the skull, you can see on my right, it can look like this. On the National Institute of Health website, we went down there and we wanted to take a look at how it occurs. Here it states that lots of the cases occur randomly, but in some cases, isolated craniosynostosis is due to a mutation in any of the several genes with an autosomal dominant inheritance. Autosomal dominance is a pattern of inherited characteristics of some genetic diseases. When it's dominant, it means that a single copy of the disease-associated mutation is enough to cause the disease. So I'm not 100% sure on this, so make sure you double check it, but it says here autosomal dominant, the affected parent. If the autosomal dominant gene is inherited by the child could be affected also. So now the funding that they got is £789,000. This is equivalent to $1,079,000 US. And remember, this is just one investigation of one genetic disease. This is the University of Oxford being the leading research organization for one disease that affects 350 babies annually in the UK. They said that finding this genetic cause is very important for many different reasons. For parents, they're able to to achieve diagnosis for their children. For clinical geneticists, it enables the correct risk to be given and to recommend the right tests. For medical teams, they'll be able to screen for specific complications. And in biochemical disorders, the information can be critical for the correct treatment. So apparently there's so many children that have craniosynostosis and they suspect a genetic cause, but they cannot identify it. In the 100,000 Genomes project, they've been using whole genome sequencing. They carefully selected 119 patients and families. And out of these carefully selected patients and families with craniosynostosis, they've only achieved 18% diagnosis. So they said, how could this be? How could we be missing, some of these genetic causes? It's because DNA sequencing technology, although it's made remarkable advances, there's still this dark matter within the genome that is poorly characterized and hard to identify. So they dropped an example here. They said 70% of the genome is made up of repetitive DNA that is hard to sequence and often gets scrambled. So this project is broken down into 4 main parts. Part number 1, they want to take a look at whole genome sequencing data, and they want to use 2 relatively new technologies, nanopore sequencing and optical mapping. These technologies look at genomes in different ways to the previous whole genome sequencing, and they're expecting to find previously unknown structural variations and copy number variants. Then they're going to carefully select these structural variations or copy number variants that they suspect causes craniosynostosis, and then they're going to make that equivalent rearrangement in mice by using genome engineering. If the mice then develop this abnormal skull growth, then they said this is going to provide them strong enough support that the rearrangement is causative of the human condition too. So they then plan to construct 4 different mouse mutants during the project. Then they're going to try a different technology that avoids the use of mice. They're going to start using human cells to change into a type of cell named the neural crests. This is going to start from using patient blood sample. They're going to construct 6 different neural crests, 6 different samples, and then finally they're going to compare the mouse tissues and the neural crest cells. So the overall goal for this project is to look at structural variants and copy number variants and find and understand the ways in which they can cause and affect not only cranial synostosis but also other diseases, by obtaining specific comparative data on all methods of genome mapping and functional assessment to improve future analysis and also find new diagnosis for patients and families. So now, before I go into the email and we talk about bionano genomics, the saphyr, with one of the people on this project, this is the planned impact of their project. They want to take a look at whole genome sequencing data generated in the 100,000 Genome Project, and they basically want to make sure they optimize diagnosis. They believe that they can double the diagnostic rate in comparison to Genomics England and the NHS laboratories, and basically they're using cranial synostosis as a demonstration project. So now, after finding out bionano genomics is being used in this project, I looked for the principal investigator and I found his student. So this is a Doctor of Philosophy medical scientist student at the MRC Wetherell Institute of Molecular Medicine. This is a research institution in Oxford, England, and this is based at Radcliffe Hospital in Oxford. So I found that Yang Pei is supervised by Andrew Wilkie. His interests are specifically in structural variants larger than 50 BPS. His project aims to identify and characterize structural variants in craniosynostosis using a variety of genomic, genetic, and molecular approaches. These include exome sequencing, bionano optical mapping. So I dropped this man an email. I said, my name is Miguel. I'm an adult nursing student at university in London. I'm super interested in genomics and I wanted to know more about how useful you're finding bionano genomics, optical genome mapping with identifying structural variants for craniosynostosis. Are your colleagues also in the 100,000 Genome Project using optical mapping to explore other structural variants for different genetic diseases? Yang Pei hit me up. He said, hi Miguel, thanks for reaching out. We've only recently started using the bionano machine and have done about 5 trios. I would say that bionano is extremely powerful in detecting and especially analyzing structural variants compared to using whole genome sequencing data from the 100,000 Genome Project. We are still in the process of systematically comparing bionano versus whole genome sequencing and possibly versus nanopore, so they're hoping to get that project too to see how they perform. But my initial feeling is that most of the clinically relevant structural variants can be detected by all 3 technologies but cannot be resolved by whole genome sequencing as clearly as the long-range technologies. And then he said for other diseases he doesn't know if anyone's using bionano genomics optical mapping. So the first thing I wanted to understand was the definition of trios. When he said he's ran 5 trios, I wanted to know, is this flow cells for the mother and the father for 5 different families? So is that 10 flow cells so far that they've used? It states here trio studies involve the testing of samples from a proband and both parents, are often used by clinical laboratories to help with the classification of genetic variants including copy number variants. So if they've done 5 5 trios, we're estimating about 10 flow cells. Now this is just a guess and an estimate, but this is one experiment. There's 119 carefully selected patients and families. So are they going to be using flow cells for both the mum, the dad and the child? 119 selected families. And remember, this is the 2020 to 2024 project. So when they start comparing bionano optical genome mapping to Oxford nanopore sequencing, if the date it was submitted was the 26th of July, how much will this project be worth? As Yang Pei said, he's compared whole genome sequencing data, bionano versus whole genome sequencing. Possibly in future they're going to do bionano versus Oxford nanopore. Now I hope you enjoyed this video. I hope you found it valuable and entertaining. Let me know your thoughts in the description box below. If there's any gaps in my knowledge that you understand, please fill me in, because I'm always learning. I'm a student myself. If you want to drop me a tip or donation, I have a PayPal link in my description box below. If you enjoyed some of this unique content, please hit me up in the comments. Let me know your thoughts and feelings. And I've got some great videos coming up which shows funding, it shows previous customers and what they're currently working on. So they get the bionano genomics saphyr machine and then they start to explore different things and start to open up more jobs too. As always, please remember, none of this is financial advice. It's for entertainment only. Please hit me with a thumbs up and I'll catch you in the next video. Mr. ALOT over and out, baby.